Hi and welcome to this video about lecture 8 part 1. So it was about the constant J plus Vogel solution of inflow-performance relationship. That's only the first part towards a nodal analysis. So at this point we haven't used nodal analysis, okay? So to show you this Excel, how you can reconstruct it. So we have given data, reservoir pressure 2200 psi, bubble pressure 1800 J, 1 bars per day per psi, and the Q max assumed to be 1000 bars per day. The thing that we're going to, you get used to is to what's called, you need to assume, okay, flow rates all the time, okay? So we start assuming 0 bars per day. That means we haven't produced for this column where we use only J constant. So at 0 flow rate we have 2200 psi. So the origin of this curve. And then after we produce 200 bars per day, we use the J constant formula, which I showed you before. It's basically, you take PR minus Q, you divide by J. You find the whole flow and pressure. Okay? Then you assume 400, another 200 bars per day. But when we assume 400 bars per day, the pressure we get is 1800 psi is the PB. That means by right we should stop J constants. But what we do here is that we carry on with J constant, okay, so that we can compare with the Vogel. Okay, so basically these data normally should not be there, but they are there so to compare. The same thing, these data should not be here for Vogel because we used already the J constant. But for Excel, to compare two equations, we need all the data set, okay? So before the bubble point in Vogel, we just replicate these data here, okay, they are the same. And then we start from here. So this, to get the pressure after the bubble point, which is 600 bars per day, we use the formula that I showed you before. It's this formula to estimate the P pressure well flowing. It equals 0.125 reservoir pressure bar here. Here you should assume PB. For Vogel, the starting point is the bubble point pressure. Minus 1 constant plus square root 81 minus 80 multiply Q over Q max. Q max is given, and Q is what we call Q Vogel. Q Vogel, we have a column for it. Okay, so what's this Q Vogel for corresponding to the 600 bars per day? It's basically the 600 minus the 400, which is QOB, the flow rate at the bubble point. Okay, then we calculate, we get this. The same thing for the 800 bars per day, the Vogel corresponding, it is again 800 minus 400 and so on. Okay, now when we plot the J constant, these ones, and then we plot at the same time the Vogel equation, what we see that up to the bubble point, it's the same thing. But from the bubble point, we see an increase of discrepancy, okay? After 400 bars per day, with 200, let's say 600 bars per day, we have a small discrepancy. But further down the production, we get a bigger discrepancy. What it means that the J constant is overestimating the reality of the reservoir after the bubble point. Okay, what does it mean again? It means that at 1200 bars per day, if you use J constant, you will estimate 1000 psi. You say that the well flowing pressure is 1000 psi, but in reality it's not. It's less than that. It's actually 700 psi. Okay? So that's what you can take from this part 1. Also, once you construct this XL, you can change, you can play around. For example, you play around with the data. Let's say the reservoir pressure is 2530 psi. So you can see it here. The origin has moved to 2530, and then you cannot see a difference. But check this: when we change again the PB, and let's say make it 2250 psi, then you can see the big discrepancy. Okay. So what it says in this first part of lecture 8 or this exercise is that you need to combine J constant up to the bubble point, and then from the bubble point onwards you need to use basically Vogel equation. Okay? Alright, see you.